All right, as Nicholas said, my name is Casey Stella. I'm going to be talking today about a natural language processing project that I work on to help analyze bias in news. So the company that I work for told me that I should say they do not know about nor do they support this project in any official means. So it's separated, so don't draw conclusions about explorers from my talk if I offend anybody. If I offend anybody, I apologize in advance.
You offend me.
Well, just my existence.
Naming a file is something from Reddit. Oh, verify against Reddit.
Verify against Reddit.
That's offensive.
Well, it shouldn't be, because it was actually useful for analysis. All right, so what we're going to talk about today. I'm going to outline the problem, we're going to talk about the approach, talk about the conclusions, and then you guys are going to hopefully ask some good questions. All right, that's the general scheme of things. All right, so the statement of the problem. News is decentralized. There's tons of places you can get news. You can get it from Reddit. If you're lame, you can get it from Dig. Maybe some people still get it from Slashdot. Some other places that now. Fox News, etc., etc. It's good. Better, more views means more information, right? Means more perspectives, greater access, etc. All these nice things. But it's also kind of bad. It's hard to detect bias. We have tons of, you can exist within a small world where you're only getting sort of a self-feeding cycle of bias. It would be nice to be able to detect that so you can break that cycle. And so you can say, look, I want a fairly balanced digest of news. So this all sort of started whenever I decided that I wanted an automatically generated podcast to replace my NPR listening in the morning. I wanted to be able to say, look, I want the same story multiple times from different perspectives at the opposite end of the political spectrum so that I could get a balanced view. And I want it read to me because I'm lazy. It's a very broad problem, right? It's a very hard problem. It's fuzzy, right? And it's a very vague problem. So this is where we started a few months ago, or maybe a couple of years ago actually. And I've been working on it ever since in my spare time here and there. And it's gone through through quite a few iterations, but this is where we are now. So the challenges. First, you need to extract text from HTML. You get a lot of noisy data. This is like a traditional problem. So the way I'm going to orient this talk is, this is sort of a traditional machine learning problem, and I'm going to step you through the traditional way to approach it. All right. You have noisy data that you need to clean. You get HTML, you want to extract the text from it, because you want to analyze the text from it. You do not care about the markup at all. That is relatively difficult, actually. You also don't care about the ads. You also don't care about a lot of things. Thankfully, some smart people are working on that problem already. There's some good libraries. So the first thing that you have to look at is, in even choosing the language that you do to code something like this, if you want to get to brass tacks, is what's the library support? That's one of the reasons why I chose Java. I'm not a fan of the Java language, but the library support for this kind of stuff is actually quite robust. So a very good German PhD student has a library called Boilerpipe that extracts text using a very novel technique. I'm not going to go into. You can look into it yourself, but it's worth reading the paper. It's also very fast. It's a perfect example of a very engineering-oriented, a very statistical solution to a very hard problem where you could have gone a very different direction. Anyway, the first thing we need to do is to be able to determine whether even a text is political or apolitical. If I'm pulling in news scores, it's not going to be conservatively biased or liberally biased, right? I need to be able to determine what it is, whether it's what its polarity is. And once I have the political text segmented out, I need to be able to determine if the text is left-leaning, right-leaning, or in the center. And most importantly, those things are vague and inherently subjective. We need to come up with an approach in machine learning language, construct a model in order to remove myself from making value judgments as much as possible. And also, I want to be as lazy as possible. So the quickest path to victory is what I'm going for. That's a very software engineering approach to a very theoretical problem, I guess. All right, so a model for political orientation. This whole thing can be tackled with natural language processing. It's a very robust field. It's it is relatively well understood for being such a young field. There's some really good work, especially being done at Stanford with this stuff. And there's some very good libraries for this stuff. The two that I would suggest looking at if you're going to look at libraries for this, if you're in the Java language, is Minor Third from Carnegie Mellon and Mallet from University of Massachusetts Amherst. They're very good for this type of problem, and they allow you to use. So when I say I'm going to be as lazy as possible, it means I'm going to treat as many things as a black box as possible. That's a double-edged sword. The less you know about what you're actually using, the tools that you're using, the more likely it's going to turn into a chainsaw and cut your arm off, right? So you have to. It's a way to drive an education. It's a way to drive personal development and education that's very practical, and you get results quickly. And the first thing, the other part, we talked about cleaning dirty data. Now we need to sample data. We need to get sample of politically oriented text, while simultaneously being extremely lazy. So hopefully, let someone else do the hard work for us. And finally, bias is really difficult to characterize. What is left, what is right, it's all subjective, et cetera, et cetera. We need to construct a model. So one approach is to map politicians onto a one-dimensional spectrum and segment the spectrum into right, left, and center. This is a traditional approach. It dates back to pre-French Revolution, the 18th century, right, where certain politicians sat on the left of the aisle, certain politicians sat on the right of the aisle, hence left and right. It's a lossy model, though. But if we can do it in such a way that I'm not the one saying these people are on the right, these people are on the left. It's not so much that I can say these people are on the right, these people are on the left. I need to say within the left, who is farther left than someone else. Right? I need an actual spectrum. I need a one-dimensional vector space. Okay. So we have speeches. That's a relatively good source of data that you can find. I happen to trip upon some, which is great because I'm lazy. So all that's left is constructing that spectrum. Okay. So thankfully, I found a data set with maybe 1,000 or so speeches from senators from the 111th Congress. Just one more recent ones in case you don't follow politics that much. All right, so first you create the model. Computational political science to the rescue. This is another very small, relatively new field. It's political scientists with stats backgrounds trying to solve problems without making value judgments. You get your Marxist historians, you get your non-Marxist historians, etc. Say, no, let's look at the data. It's a data-driven approach to political science. I happen to be a fan of data-driven approaches to things. All right, so the idea is to use roll call votes to fit senators onto the 1D spectrum from left to right. So in this talk, I'm going to treat the stats and the machine learning in large part. I'm going to give you a flavor, but I'm going to treat it as a black box because I am lazy. It's a theme. There is a theme. Okay, so senators vote. They cluster together. Senators that vote similarly cluster together. So it turns out this is a simple logistical regression problem, and actually the model is one pulled from education. You can look it up if you want to. If you Google ideal point analysis, or the RASCH model, R-A-S-C-H, this is an approach. The idea is you fit bills onto the spectrum that they're voting for, and you fit senators onto the spectrum in such a way that the proximity to the bill for a senator is in direct proportion to the probability that he will vote yes on that bill. So this gives us a fitting onto a one-dimensional spectrum for politicians. So I can say now that Senator Kerry is to the right or the left of Senator Kennedy. All right, which is nice. That solves the problem. And it solves in such a way that the model is validated. And it happens to be one of the more popular models. And it happens to be computationally feasible, which is nice as well. It's a simple logistical regression, Bayesian analysis, simple statistics if you're a statistician, which I am not. All right, so hard statistics is done for me already by the good people at voteview.com it's a computational political science outfit that does, use analysis, fits politicians onto a spectrum, etc. So as you can imagine, this also scales out to many dimensions. You can have two-dimensional, three-dimensional data. They've looked at it. It's hard to actually start reasoning once you get past one-dimensional because humans like to fit politicians onto a one-dimensional spectrum. Anyway, obviously the model is a simplification, but it seems to work for us. I can explain it to my grandmother, at least, that this politician is to the left of that politician. Okay, so now on to the machine learning. Now that we have the senators fit onto a spectrum, we can look at a set of documents associated with those political orientations and then map them onto the spectrum. And I can say this document is to the left of this document. So now I've constructed a partial order on the document set and in the document space. So that means I can split my data set into training set and testing set because I know this document is to the left of this document, etc. So all I have to do is split the spectrum. So I say, all right, I want to split so that center is defined as 3/8 of the whole line, and then the rest on the edges are the far fringes that I want to move out. I don't want to see. I want to see just the center. Or maybe I want to see the left and the right, etc. And the way you figure that out, the way I figured it out, was empirical. I looked at what gave me the best results. And by the way, if anyone has questions, go ahead and ask. It's cool. All right. And it's a great test bed for different machine learning algorithms for natural language processing. And I didn't really have to implement them because I use good libraries because I'm lazy. All right. The new hotness is adaptively boosted decision trees. Actually, the new hotness is random forests, but we won't go into that. Adaptively boosted decision trees. A decision tree is, you can think of it like a big if-else chain. Is there anyone at AI right now? You might have gone over decision trees. You can construct decision trees automatically from looking at observations. This is associated with this. You have a sample set. You can construct a decision tree that says, if this attribute and this attribute and this attribute, you can go down the decision tree. Just like you would normally make a decision, like a flow chart. But you can automatically construct it. The problem is these are weak classifiers. And when I say weak, I mean they're not very accurate. What adaptively boosted decision trees are is they say it's a meta-learning algorithm. And what I mean by that, I can say I can construct many decision trees, and then I can take linear combination. I can take weighted combinations of those decision trees to make a better, to draw a better conclusion. So that is what seemed to work the best. No, that's just a description of what I just said. All right. So it's boosted. Now I say I'm going to choose the middle 5/8 of the data to be my center of what I consider center, as opposed to left and right. Total accuracy. So this is the evaluation. So this is the best I got. Total accuracy within 95% with our error bars for any statisticians there. Good mathematicians. So I got my error bars there. 78% plus or minus. Sorry, that should be 4%. Plus or minus 4%. And this is what's called a confusion matrix. Down here is what it was actually, and here's what we predicted. These are counts, and this is percentage. So along the diagonal, I predicted there were 46 left-leaning documents, and I predicted, or rather there were 66 total left-leaning documents, and I predicted 46 as actually being in the right category. 16 of those I predicted as actually being center, which is a huge chunk there. But I only mispredicted 4. So what I'm going for, so the point of this is, the simple accuracy isn't sufficient to actually get the whole picture, right? Even with the error bars. What I really need to look at is I need to figure out, I'm already assuming I'm gonna make errors because I'm lazy. I need to figure out what kind of errors are okay for me. I made the decision that I wanted to make sure that it was very, very unlikely for me to pick something from the left wing and misclassifying as all the way to the right wing. But it was okay for the left and the right to bleed a little bit into the center. But I wanted to minimize that. So you see, 6%, 0% misclassification for left and right. Yeah.
Now, whenever you say centrist, could that also be unbiased though?
Exactly. It can mean unbiased. So this is what we're gonna. You put your finger on a good point. What I actually solved might have been a completely different problem. And what does bias mean? Just because it's left to the right doesn't necessarily mean it's bias, right? It could mean that it's just this is. It could mean. So I did very well comparing. I did very well comparing speeches against other speeches. But maybe I'll do very poorly comparing speeches against like noisy data that I pull from the internet. Like if I look at a Reddit comment, it's going to be very different than a speech by Teddy Kennedy. Let me tell you. But yes, the point is absolutely it could be non-biased. It could be non-biased. It could be centrist. It has a lot of interpretations. But I do know that I want to make sure that I cut off the fringes. Anything that's not like the fringes, I want to cut off. So that's still an open question as to what it actually means, or what this is that I've created ultimately, what the tool is useful for. All right, so we'll put that on the back burner for a little bit, and I'll talk more about that in the conclusions. But the second part is classifying text as political or apolitical. All right, so this is actually the only part of this where I actually had to do a little bit of work and think. And I'm lazy, so I didn't like that very much. In fact, it's the reason why it took many months. Thinking is hard. It hurt. It's awful. Anyway, so we want to look for bias in political text. So we need to know which texts have political content. I want to ignore ESPN, maybe. Maybe not all of ESPN, but most of ESPN. All right, so what do? So the new hotness also in natural language processing is generative topic models. Latent Dirichlet allocation. What is that? A bunch of words, French name in it, bring me to the ACM, talk to a bunch of computer scientists about math and stats. Awful, I'm sorry, I apologize ahead of time. What that is you can construct a vector. The idea is you can construct a vector space. And the basis of the vector space, I'm going to explain that in a minute. The basis of the vector space is your topics. So that means that given a document, I can model that document as a linear combination of topics. So a perfect example of that is if I consider topics V1 and V2. And maybe they roughly represent healthcare and the war in Iraq. You can represent a story about hospitals in a war zone as maybe 0.2 of healthcare, but 0.9 the war in Iraq. And a story about hospitals closing is nothing about the war in Iraq, but 0.8 about healthcare. Not an idealized model. The point is, it's unsupervised. It applies, it treats, so it takes a corpus of documents, it constructs that, it constructs those vectors and a way to map new documents that it hasn't seen before into that vector space without having to give it examples of the topics. So it finds connections if words are similar in two documents, it handles a lot of that stuff for you. It's a statistical model of language. And it works fairly well. At any rate, it's very nice, because now, this is an example of a very traditional approach to solving a machine learning problem. Again, I'm going to transform a problem that's very fuzzy, that deals with a bunch of strings, as a linear algebra problem, which I know how to deal with much better. I'm much more capable of dealing with a linear algebra problem, because I have much more machinery. So you pick the hill you want to die on, right? And if I know about linear algebra, I'm going to shift the train. I'm going to make sure I'm fighting on that battlefield, right? Okay, so I have all these senatorial speeches. I can construct a vector space on top of those speeches that where the topics are the basis vectors, and I can represent new documents as linear combinations of those topics. Now, I can use distance metrics. So I can say this document is close to this document because it's close in the vector space. That's very useful. The problem is, it still doesn't solve my problem. What the problem, as you recall, is figuring out whether or not text is political or apolitical. Okay, so I have these documents that I've constructed the vector space out of. I have a set of them that I know are political. They're talking about political things because senators rarely talk about apolitical things. So at least not in the press, or else they wouldn't be keeping the job very long. I hope. So, we have an example. What do we need now? We can roughly define, if we can define a metric such that the length of a particular vector is less than some constant, then that I can conclude that document is political or apolitical. In other words, the idea is that I can draw a big, assuming it's two-dimensional, I can draw a big circle and say everything in the circle is political, and everything out of the circle is apolitical. I already have a bunch of examples of documents that are in the circle. So all I have to do is construct the circle. Okay, so the trick now becomes finding that metric. As I said, there are things called statistical distance metrics. And they're useful, especially if you are dealing with fuzzy types of problems, machine learning types of problems, statistics problems. So this is sort of bringing in stats again. You'll notice there's a lot of bleed over from stats into this. It's not all computer science. Mahalanobis distance. Mahalanobis distance. The background behind this is that this dude, Mahalanobis, was trying to figure out, he had a bunch of skulls. Some of them were monkey, some of them were monkey skulls of a certain type, some of them were monkey skulls of a different type. He wanted to cluster those skulls together. But he knew that there were certain ones that were actually absolutely of this type, and he needed to draw that circle like I needed to draw. So I, much like Dr. Monkey Skull, had the same problem. What it does is, if you have a set of documents that you know are in the circle, you can construct a distance metric that's essentially the distance from the center of mass, but it has some nice mathematical properties. One, it's invariant to scaling, so that means that if you have more than two dimensions, you start dealing with like a z coordinate that goes all the way, that way for a few miles. It's going to handle that nicely. And these topic models, we're dealing with a 250-dimensional vector space. So it's really hard to reason about that. So I need a distance metric. I can't rely on my intuition, geometric intuition. So really, a lot of it is just a simple Euclidean distance that's sort of tempered by the correlation matrix. You can look it up on Wikipedia if you want. It's actually pretty straightforward stats. It's a fairly obvious approach, but it works fairly well, I think. The only unfortunate part is I haven't gotten around to actually evaluating how well it works. But I will say this: it seems to work well empirically. Whenever I just kind of type in a URL and pull the data down and then look at the topic vectors, they seem to roughly correspond, and it roughly corresponds to whether the thing is political or not. So That's kind of a work in progress. Yeah.
Now, this may be jumping ahead a little bit,
Mhm.
but whenever you start distributing this, do you plan to have some sort of method to allow users to rate to rate the accuracy of it?
No, I don't plan on distributing it at all. It's just, the code is distributed already via GitHub, but.
Yeah, I've been looking at it.
So, like, for instance, yeah, so the question is whether I should allow users to rate it. And, yeah, you could definitely do that. You could get some feedback. Factoring that feedback into the model is relatively difficult, though. You have to make sure that it almost becomes another meta-learning algorithm on top of that, where you construct a set of, multiple classifiers, maybe one for each person, and you start weighting them together. I mean, it becomes a difficult problem. It's one of the reasons why this kind of thing hasn't happened. I've also thought about using the LDA, using LDA to construct a vector space and allow people to say, I only want news about this topic.
Mhm.
Which is nice, because it automatically generates. The more data you get, the more refined the topic model becomes. It's actually really interesting. If you ever get around to it, try to run LDA, which has a great implementation in the mallet toolkit, if you're interested in Java, if you can write Java.
What does it stand for?
Mallet?
No, LDA.
Latent Dirichlet allocation.
Got it.
So if you do that, it's really interesting to run it over Wikipedia. You get some really cool, like, categories. Anyway, all right, so what did we learn? Using good libraries allows you to continue to be lazy and solve hard problems, right, which is nice. I like being lazy. I think I might have solved the wrong problem. I'm not sure this actually solved the problem that I was trying to solve. I think what it might have solved was figuring out which internet forums and blog postings were closest to senatorial speeches rather than closest to liberal senatorials. Maybe, I mean, it probably solved which were close to liberal senatorial speeches. That's the refinement. Which brings me, I think, to this point. You have to clean your data. If you're testing on clean data, if you're evaluating on noisy data and you're testing and constructing your machine learning algorithm on clean data, there's an impedance mismatch there. You have to be careful. It's kind of like a Wolverine on a leash. You don't want to let it off the leash, and if you do, you never are quite sure when it's going to turn around and eat your face off. It's very powerful, but sometimes when you go to find liberal or conservative bias, you find liberal or conservative senatorial similarity. Yeah, so I'll just reiterate, cleaning data is very important. Very, very important. All right, so thanks for your attention. If you have any questions, go ahead. Oh, by the way, Explorus is hiring. We're a big data startup in Cleveland. I'll give the spiel just real quick. We're a big data startup in Cleveland. We do medical informatics. There's stats, there's big data, there's computer science. We get to deal with B+ trees and all the nice low-level stuff and the high-level stuff. And it's a cool company.
I'd just like to add, I interned there over the summer, and it's a great place to work. I think you'd all be happy there.
So you can find me there. If you have any questions, ask away. So this is the second time I've given a talk in this auditorium. The first time I gave a talk, he was in the crowd, and no one asked any questions. So if you have any questions, do ask. I will not bite. Unlike machine learning, am not like a Wolverine on a leash. Yes.
Now, because I was looking through your code while you were talking.
Oh, I'm sorry for the terribleness of that code.
It's not bad. The one thing I was having a bit of trouble understanding was what exactly you were scanning, because it seemed like a lot of it was Reddit based. So were you scanning mainly Reddit?
So I wanted to evaluate how this worked on noisy data. So what I did was I took r/liberal and r/conservative and figured that I'll let Reddit users figure out what the hell is liberal and what's conservative. And so I scraped them, I pulled it down, I looked at that, and I evaluated the machine learning algorithm on that and tried to figure out how effective that was.
So what your evaluations really are saying is how closely the hive mind matches speeches.
Exactly. The problem is Reddit's r/conservative is fairly liberal. And Reddit's r/liberal is downright frickin' left Marxist wing, you know, crazy, cuckoo bananas sometimes.
So when you constructed your spectrum of the speeches,
Yep.
you were constructing it comparing roll call
votes.
comparing roll call votes to the speeches. How did you evaluate where the speeches lay on the spectrum, or was it just?
So the speeches were a senator's speech associated with the senator's position. So that is
So how did you evaluate a senator's position?
So you evaluate the senator position by essentially clustering the senator based on the senators who are similar. You fix a 0 point and you cluster the senators who vote similarly together, but in reference to that 0 point.
Right, but how did you evaluate which bills were left or right?
So
It's turtles all the way down.
it is turtles all the way down. You have to
Bias all the way down.
you have to kind of figure it out. But the one thing I will say is once you pick an orientation, because left and right is really kind of arbitrary, right? It really is. It doesn't matter whether you go from the left or the right. You just need to cluster the senators together. But I will say this: once you look at it, you'll be able to tell who clusters together. You know, ain't no way Teddy Kennedy's to the right. But I will say this: it's 90% accurate. It's over 90% accurate.
What are you evaluating the accuracy of that against?
Against other, so it's the same way. I didn't evaluate the accuracy of that. That's actually from research. But what you would do is you would split it up. You would say, okay, I'm going to develop the model on a training set, then I'm going to evaluate it on a testing set. So new bills or new senators, you can predict how they vote based around where the bill gets mapped. Yep.
Now, did you try unleashing this on anything other than Reddit?
No, not yet. I mostly just kind of tinkered around and put in things that I knew that were probably liberal and probably conservative. I mean, it was actually relatively good at doing that. And the command line program there actually will do that. You have to generate the LDA model, which there's no instructions about. I should probably write up instructions. I'll do that this week.
You should just Ruby in there.
So when are you making the jump to your personal podcast that we read to?
It'll be interesting once you have the classifier, all you have to do is pull the data in and obviously strip it of markup and then do or text to speech. Which isn't that hard? You can use oh gosh, the thing from Edinburgh. I can't remember that name. Festival. You can use Festival to do that.
Last time I used that, it wasn't very good.
It's terrible, but it's open source and it's free, and I can't afford Dragon or any of the commercial ones.
What about
I'm poor because I'm lazy.
What about the Android one?
What's that?
What about the Android one?
I thought macOS had pretty good.
The Android one is what I'm talking about. I think, isn't it?
I'm not sure what the name of it is, but I'm just
I
curious.
thought macOS had speech to text baked in.
There is, but it's really bad.
Really?
Yeah, have you listened to it? It's pretty awful.
I don't have a Mac.
Yeah, I don't know.
So will the voice be robotic? So that way it gives it.
I was hoping a
bias?
nice, gentle British voice
No.
that will soothe
Stephen.
me on my morning drive,
Stephen
so I don't
Fry.
get angry. Exactly, I'm Stephen Fry. I'm thinking.
You should get the Garmin download the GPS with Snoop Dogg voice.
Since you're already scraping Reddit, have you considered requesting Reddit users to record your podcast?
I should. I should do exactly that. Any other questions? Yeah.
I have questions about, when you're talking about the topic models at the end,
Yep.
so is it categories predefined?
No, they're not predefined. It's a generative model. So that means what I mean when I say a generative model is there is a statistical process by which connections between the text, but when you treat the text as a bag of words model. So what that means is words can order of words don't matter. You can construct the topics by connecting similar documents with similar words. That's the general way that it's approached. It's actually relatively complicated. So if you're interested in LDA, the place to look for that is there's a professor at Berkeley named David Bly, I believe. First, Wikipedia. Second, you can look at this guy's code. He's got a C library out there that I ported to Java a few years ago. And Mallet has an actual very good implementation of LDA. But to answer your question, for the record, it is unsupervised, and the topics are constructed. You give it the number of topics, and it will construct that number of topics. Practically, 250, 150 to 250 topics seem to work very well.
Do you need to remove the stop words from the document?
Yes, that's a very good question. Cleaning data. I mentioned you should clean data, but I didn't mention how you clean data. Thank you for holding me accountable. This is Ron. She works for Explorers as well. She's on the data grid team. We just do processing together. It's great. It's a fun time. Yes, you have to clean the data. So here's the way to clean natural language text. Once you have removed the obvious markup and all that mess as much as you possibly can, you want to stem the words. What that means is, if you're dealing in English, which is a nice simplification, or some Indo-European language, you can do what's called porter stemming. Porter stemming will do things like, in an automated way, because English words follow some approach to a rule set. You can strip off tense, it's like that. So giving becomes GIV, gave becomes GIV, like that. Okay, so now you have that. You have the words mapped. Then you have a series of stop words. So most of English is words that don't contribute to the context when you take the words as a bag of words. What that means is if you ignore the order in which I speak, you just treat it as a bag of words, most of the words that I say are going to be things like a, and, the, etc. That's not going to really help construct that topic model. So you remove those. Mallet does a lot of the stuff for you. You can specify the traditional stop words. It's analyzed. These guys have analyzed a lot of natural language text and figured out the top 90% of the words, and then dropped all of those. And the bottom 10% are the things that actually contribute to the meaning and meat of what you say. Yes.
Now, I understand that this is your idea, but are there any other competitors out there that are similar to this, that you would say are maybe striving towards the same thing?
Not that I know of. So here's the problem. It's really hard to distribute this. So just because I work in distributed processing, I do know about this kind of stuff. There is, if you have a large amount of data that you need to run LDA on, or construct a support vector machine or a machine learning algorithm, there's the Mahout project, M-A-H-O-U-T. You can distribute LDA, but it's kind of shitty. Excuse me. It's kind of crappy. There's, and the reason why is because something called Gibbs sampling. I don't know if anyone's familiar with this, but Gibbs sampling is not able to be done using MapReduce. That's the reason why it's kind of crappy. Yep.
Do you first extract topicals from the document first?
Extract the what?
Extract topicals.
Extract topics from the document?
From all document you collected from the website.
Yeah, so I actually extracted the topics, or I generated the topics from the senatorial speeches.
Yes, and then you classified from these topicals.
I classified new documents from those topics, yes. So the question I think you're getting at is, am I cheating? Right, which is good, it's a good question. So if you generate the topics from the same set of data that you're looking at, evaluating, are you cheating? And you can make an argument that you are, and the reason why I don't think that I am is because I got about the same results generating the topic from Wikipedia.
Okay. And
Yep.
for example, the topical number is fixed. If you want to run the LDA, the K, which means the topical number, you must fix it first. And
You must fix it, yes.
Yeah. So you should, I think the K should be, you must set several numbers.
Yeah,
Okay.
so you have to look at it.
Yeah.
So you have to evaluate this, a number, a lot of this was like exactly what you're saying. You look at it, you look at how many topics, so the K gives you the dimension of the vector. It gives you the dimension of the vector space.
That
Right.
is sensitive to the result.
It's very sensitive to the results. The reason why I say 150 to 250 seems to work fairly well, and you need a fair amount of data to do it. But the way that you do that is, the way that I approach this is empirically. You look at it, you run it for many times, you do the evaluation, you figure out which one is the best. Right. But those are good questions, absolutely.
So you were doing better than last time.
What's that?
You're doing better than your last talk.
What was wrong with the last talk? Oh, the questions, yeah, absolutely, yeah. I can't even talk to the STEM talk, or to the STEM group, which I cannot say,
No one wanted to be there.
no one, why did
We
no
were
one want to be there?
required.
I was awesome. I was like all
Hey, you got me on Reddit, so.
All right, fine. Read Reddit. People should read Reddit, more people.
And Stack Overflow.
And Stack Overflow.
And Hacker News.
Yeah, absolutely. Hacker News is very, very good for technical.
It's getting out there really fast.
So one of the reasons why I kind of ratcheted down on this is because my news, so the reason why I constructed this is when I'm at work, I read a lot of technical blogs and technical news. The only time I really get to not do that is when I'm not around a computer. So this is one of the reasons why it's actually.
So, did you ever think about whenever you were to let's say you were to legion on the web, did you ever think about maybe like classifying authors as left, right, or?
Sure, you could do, I mean, it's a fairly general approach. You have to change your, I mean, absolutely, you could definitely do that. You could definitely do that. I don't know how effective it would be. This is very fuzzy and it gets very, very bad. I mean, a lot of times your gut, it disagrees with your gut.
Oh, yeah.
How resilient is it to, for example, spelling errors? Like, if you have a lot of spelling errors, is it going to?
Porter stemming should give you some resiliency to spelling errors. Simple transposition, things like that. It's a good question. One of the things that you can do is build in better resiliency to spelling errors, right? You can do, so, one thing that you can do that I've considered was, has anyone ever heard of, you ever heard of Jar-Winkler distance? It's a different distance metric. What it is it's a ranking of similarity between two words based around common misspellings in English. So if you find a word that's very similar to another word using Jar-Winkler distance, do that. And there's the traditional approach of using of the spelling correction. You can do if you're Lucene has, there's some recent research from MIT on something called Levenstein automata. So what that means is it's a way to quickly evaluate a large number of documents and say if they're different within like one or two edit distances of each other, then they're the same. And when I say edit distance, I mean if you exchange one letter or you transpose one letter, those count as like one. It's a tip. Go ahead.
Why not unleash this on Twitter?
You could release it on Twitter. Okay, here's the problem with Twitter. And actually, I'm a part of. I'll give a shout out to the second startup that I'm a part of. Dream Kuma. It was recently started by some buddies of mine where we're looking at. Let me get back to your question, but this is related. It's a startup that looks at. It allows you to type in dreams on Facebook, and it's a Facebook app, and it lets you, get support for your friends or whatever. The reason why I'm involved is because, honestly, that great of an idea, but it's actually interesting because you want to find similar dreams. Dreams are very short, just like tweets, right? Short text contains very little context. So the problem is you need to augment so you need to add fidelity without adding too much noise to short amounts of text. That's a hard problem. I could go into that here. That's a whole different talk entirely. But I'll give you just a one-word suggestion. Look into locality-sensitive hashing. It's very, very interesting.
3 words.
Sorry, 3 words. Locality-sensitive hashing.
But that's kind of.
So if you looked at Twitter, yes,
Well,
absolutely.
I guess that's kind of the opposite response I was expecting, because you have a very, very short amount of text there that should be able to be parsed and understood relatively easy.
If I give you a short amount of text, am I going to relay more context or less context?
Well, no, but to determine, because there's key talking points that you're looking at here, all right? So, for example, if you're looking at something that's more Republican, something that's like, Obamacare, all right, is obviously going to be leaning more towards the right. And being able to focus on keywords is obviously where Twitter's taken off and been able to do searching.
Machine learning is like a drunk playing darts. He's going to throw it at the dartboard 15 times. He's not going to hit it that many times. he's gonna throw at the dartboard 50 times, he's gonna hit it far more because he's kind of refining. The more data that you have, the more likely that its mistakes, which it's going to make, are going to be outweighed by its correctness.
Fair point.
It's also a Wolverine. It's like a drunken Wolverine, like darts. The takeaway of the talk, easily. And I'm lazy. Okay. Thanks for listening.
TCM
Glad they're on
people-
about machine learning.
ACM people should stay because we have to vote on ratifying the charter.